Hello, Mr. Array, right?
Yeah.
So let's take a look at this array. So we talk about the concept of subarray or sublist before, right? And we also talk about subsequent. Do you still remember what's the difference? What's the difference between subarray, sublist, or...
One of them is continuous and others you can just pick out numbers.
That's right, so which one is continuous? Yeah.
Is it the bottom one?
No, the opposite. Okay, but it doesn't matter. Actually, it doesn't matter. But as long as you understand that one is continuous, one is not, right? These just the different names we're calling it, right? Okay. Subarray and sublist are continuous. Yeah. Subsequent is obtained by removing 0 or more elements from an array. So, for example, if I can remove these 2, remove this 1, and the remaining is 10, 5, 10, right? This is the subsequent. The subarray is continuous. Sublist, right? 10, 20, 20, 30, 20, 35, okay? Subarray, if a problem is a subarray, then usually we can do it in O(n) square time, right? O(n) square. Subarray continues, so it means that if we have a left and if we have a right, then we can determine a subarray, right? How many different subarrays? If there are n elements in the array, there are how many? So each individual element is a subarray, right? So this Cn1. N choice, we pick one. N element, we pick one. Or, if the subarray contains more than one element, it's Cn2. Alright? There are n numbers, we pick one. One single number is a subarray, it's also a subsequent. Subarray is a subsequent, but not the vice versa, right? And this one, picking 2. What does it mean by picking 2? It will pick this one and pick another one. Pick 2 numbers out of the array and then use it as the leftmost or rightmost. Right? For example, if we pick 10 and 5, and then we have a subarray which is 10, 20, 35. If we pick 20 and we pick 50, it means we have a subarray 20, 35, 10, 50. Make sense? Okay. Subsequence usually it's the naive solution, the Bruteforce solution is O2 to the power of n. Subsequent, each element we have 2 choices. We pick or not pick, right? 2. The second element we have 2 choices. Pick or not pick, right? There are n elements, so 2 times 2 times 2 times 2 times n times, that's 2 to the power of n. Okay, so let's come back to this question. So we want to find out the subarray, right, containing the max possible sum. However, there's only one requirement, which is it has to be ascending. Can you tell me which subarrays here in this one is ascending, containing ascending numbers, so increasing, right?
10, 20, 30.
Yeah, and
5, 10, 50.
okay, so we have 2, right? So which one has the most sum?
5, 10, 50.
Yeah, which is 65. Okay, so the question needs to be answered 65. Ascending, ascending. This is quite similar to longest increasing subsequent, not necessarily continuous. Longest increasing subsequent, we use the dynamic programming and greedy binary search. We talked about that a long time ago, right? But today, we are focusing on subarray, which is the maximum increasing subarray sum, okay?
Is there going to be negative numbers?
That's a very good question.
You get the ascending kind of group and do maths and add them.
Yeah, okay. The most naive solution, which will be, I just said, O(n) square, right? We do this, right? For I in range n, the left, yeah? For j in range, we start from the I, right? To n. And then the subarray is what? Subarray is number ARR I to j plus 1, right? To j plus 1, meaning inclusive j, right? So then we have to check if s is increasing, strictly increasing, right? If it's strictly increasing, then answer at the beginning is 0. Answer equals maximum of answer and then sum of s, right? Yeah? So return answer. So what's the time complexity if you're looking at this naive solution? Yeah. O(n) On square. This is On. To check if the array is strictly increasing. That's On. So here, On. And here is On, but this is in the same, so linear time here, right? Alright, so On cubic. A naive solution is On cubic. Do we have a better solution? 10, 30, 60. Oh, this is too small. So I start 5, 15, 65. So what did Daddy do?
You add along the way, and if it's too small, you restart.
Restart when it's too small. Perfect. This is like a land, and then if it's too small, it means there's a river, right? Okay. So we are basically finding the size, maximum size of the land, and you can think of it as river, and then we jump. When we jump to the next one, land, we have to reset the counter, right? Okay. So we have a answer at the beginning is 0, and we have a current sum, which is 0. Okay. Look, 10. Yeah. The answer is the maximum of this current answer, right? 10. Plus 20, right? Is it still increasing? Plus 20. So plus 20 here. Plus 30. Plus 30 here, right? Okay, so the next one is smaller, right? So we have to reset it to 5, right? Now look, 5 compared to the answer is smaller, so we just ignore it, right? 5 plus the next one is increasing, plus 10, right? 15 is smaller than the maximum we have seen so far, we just ignore it. And now 5 plus 10 plus 50, right? What's the sum? 65. 65 is larger than current best. We update the current best to 65. Make sense? Which one is better? Which one is quicker?
Left.
This one is quicker because we're just going through once. But for this one, I have to go through this, and then for each I, we have to go through J, and then again to calculate the sum of the subarray, right? And for this one, the time complexity, On times this one, checking if it's strictly increasing. This is taking another On times, so On cubic, right? The sum, we can do this accumulate sum. So for this one, it doesn't necessarily take On. We can optimize this bit to O1. But still, this overall time complexity is On times On, which is On cubic, okay, for this one. Okay, so let's implement this a little bit, okay? Think about it, what have you learned, okay? I'm going to ask you a question later. Define, this is the max increasing subarray sum, okay? Array. N equals the length. We first of all get the length. How many elements in an array? If not n, if it's an empty array, we just return 0, right? If you give me nothing, then simply answer 0. Answer equals current sum equals the first number, is ARR 0. Then for I in range 1 to n. Right? So look, 10, 20, 30, 5, 10, 50, right? So we start with this number, second number, by comparing to the previous one, right? So look, if ARRI is bigger than the previous one, which is ARRI minus 1, right? So look, we are here, ARRI. This one number is bigger than the previous one, so it's increasing, right? So increasing, then current, this is the current sum. Current sum plus equals ARRI, right? Because current at the beginning is set to the first number, right? Now we have 20. So 20 is bigger than the previous number. So the sum is 30, am I right? Else, okay, you tell me what's this. If it's not strictly bigger, what should we do? If this number is not bigger than the previous number, so what should we do here? This number is bigger than the previous one, so the sum is 30. If this number is like 5, so what's the sum of this current length?
5.
So current equals, this is ARRI. This is ARRI minus 1, okay? Current, what's current? Current means the sum of the current increasing subarray. So if this number is bigger than the previous one, so the current increasing sum, the sum of current increasing subarray plus 20, am I right?
Mm.
Now look, if this is 5 or 6, smaller than the previous number, the current increasing sum should be set to which number? Should be set to which number? Because we are restarting with counting.
Array I.
Current array I, okay? Now current sum, we have this current, we have the current sum, which is the sum of the current increasing subarray. So here we need to update it, check the maximum. Answer equals max current and the second parameter?
Answer.
Yeah. Every time the answer stores maximum current, yeah? And then return
Answer.
answer. Okay. Time complexity.
N.
What's n?
The numbers.
N is the numbers. Does it make sense? What's n?
The numbers.
What numbers?
That numbers.
N. Okay, so n is what numbers? Yeah.
Those.
Oh, n. What's n? N means
It's the numbers.
what numbers?
Those numbers.
So what about those numbers? Is it a particular number or what? We are given an array. What's n?
Array.
Array. Is it a number?
Yes.
What number? Okay, so in this
Those
case,
numbers.
what those number? It's a single number or it's array? O n. When we talk about array,
Yeah.
what do you understand? What's O n?
It's the you need to take the amount of those numbers.
Okay, so look, O n. N is the number of elements in the array. So what's O n? O n means that when the size, look, if this is 5, this is 6 elements. If this array contains 600, right? So what happened? The time complexity, so it's a linear here. This is n, this is t time, so it's linear O n, right? It describes how the complexity scale with the size of the problem. The n is the size of the problem, which is the number of the numbers. The number of the numbers. Make sense?
Yeah.
So look, if
the number of the numbers is the numbers.
yeah, but it's not very clear when you describe it. We make it 10 times more of the size. The size become 10 times more. The time spanning, the time complexity spanning will be 10 times more. That's O n, right? Linear, right? But look, O n squared will be like that, right? O log n will be like that, right? So it describes the complexity. So which one is better? Obviously log n, right? N increases the scale, the size, the scale of the time complexity does not increase so much as linear or quadratic. We call it this quadratic, yeah? The space complexity. Are we using any?
1.
O1. We are using constant space. O1 means we are using constant space. Look, n here. Answer, current. These are only 3 variables. And possibly here, yeah? 4 variables. 1, 2, 3, 4. 4 variables. When the size of the array gets to a million, how many variables do we need?
4.
When this size of the element gets to a trillion, a billion, whatever, how many variables?
4.
That's right, O1, constant. What's O1 here? Yeah. It's here. Look, this is X, this is Y, right? 1 is here. So when the n increases, the value doesn't change, right? That's what it means, O1. Okay, what have you learned today?
About numbers, and you're gonna find the the greatest sum of a subarray and its ascending subarray, and yeah.
That's the problem. And how we doing it?
We are doing it by, we have 2 solutions, and that one is the one when you go through the numbers of the numbers, and you plus the numbers on the way, and if you have a drop to a smaller number, you restart and restart the current and at the end you get the greatest, look for the greatest current and then that's the answer.
Well done, perfect. Let me repeat, okay, to sum up. So today we describe a problem. We want to find out the maximum sum of the increasing subarray, right? And we can use the brute force, the most straightforward solution, most intuitive solution, which is to iterate over those subarray. And we can do this in O(n) squared to go over those actual subarrays. But again, when we get a subarray, we need to check if it's strictly increasing, and that takes O(n) time. If it's strictly increasing, we calculate the sum, which could be accumulated, right? It doesn't have to be linear to calculate the sum of the subarray. So that takes O(n) cubic. That's too slow, way too slow. The way we're proposing here, is that we keep tracking of two variables. One is the global maximum. The other one is the current sum of the increasing subarray, right? So we check if currently, if we have this increasing subarray. If it is, then we updated the current sum and we update the global maximum. Otherwise, if the next number, if we meet a new number which is decreasing or it's equal, then we have to reset the current sum. Alright? We have to reset the current sum.
Yeah.
So this is O(n) time because we just simply go to the array once. The space complexity is O(1) constant. And we're using constant space. Okay, that's it for today. Bye bye.
Bye bye.
Nice.
Hello.
Hello, Ryan.
Yeah.
Look, we are given this array of numbers, positive numbers, for simplicity. So we want to find out the maximum possible sum of a subarray which is ascending. So subarray and or sublist, right? We talk about the concept of subarray, sublist, and subsequence. Do you still remember what's the difference? Which one is continuous, which one is not? Subarray is continuous, it's continuous. Subsequence is not, right? Subsequence is obtained by removing 0 or more elements from the original array. For example, I can remove any possible combination of the arrays, and the remaining is the subsequence. Subarray is continuous, so basically you have a left and right, and everything continuous. That's a subarray, right? Continuous. So we want to find out the possible maximum sum of subarray, right? Continuous. And the only requirement is that the subarray contains the ascending numbers. So it has to be ascending, right? There's one problem we used to look at, which is the longest increasing subsequent, right? And we use the two ways. One is the dynamic programming, the other one is the greedy reasonable binary search for that, right? Given this, what's the maximum sum of subarray which has the increasing numbers? Can you find it? So we want to find out the max sum of subarray which is increasing, right? So for example, 10, 20, 30, this is a subarray, it's increasing, right? So the sum is 60.
There's 10, 20, 30, 5, 10, and 5.
Okay, yes. So this one, and this one. So which one has the largest sum?
No, the second one doesn't include the last 5. It's only 5, 10.
Okay, yeah, you're right. Actually, this is 50, okay?
The
Yeah.
second one.
Second one, that's 65, okay? You're right, 65. Yeah? One number is the increasing subarray. For the second example, what's the maximum sum of increasing subarray?
10, 20, 30, 40, 50.
Yeah, everything, because it's increasing, okay? And how about the third one?
10, 11, 12.
We're down 10, 11, 12, yeah? This is bigger than that, right? How do you find out the second one is the increasing? How do you know it's increasing? Just look at it. And then it's all increasing, it's increasing. And how about this one?
Only 10, 20, or 30.
Yeah? But now,
5, 10.
so what happens when the next number is smaller? It's not increasing anymore.
Yeah, you look from that one.
You found another one. We start here, right?
Yes.
Okay, so yes, you're right. Yes. So let's look at this. We keep tracking of the sum of the current sublist. Right? If we break it somehow, if we move to a smaller number, which is or equal number, which is not increasing anymore, then we reset the sum. Alright? We reset the sum and we accumulate again. And then in the meanwhile, we have to keep tracking of a global maximum. Alright? Current sum equals 0 and the maximum equals 0. First of all, we start with the first one. So current sum is 10. Maximum is 10, right? Because every single number is increasing subarray. The next one is bigger. So the current sum plus 20, alright? Is bigger. The maximum sum 10 and 30, which is 30 bigger, right? And then plus 30.
60.
60. And 60 and max 30. 60 is bigger, right? So we update this 60. Okay, what happened here? 5. We don't add the 5, right? So instead we change it to 5. 60 and 5. 60. We keep 60. 10. What happened? 15, right? 15 and 60. We keep 60. And then next one. 65. 65 and 60. We keep 65, right? That's why we find the 65. Okay, let's try this example. Okay. The current sum equals 12, which defaulted to the first number. The maximum sum, which is 12 as well. Okay, 12 and 70 plus 70. Obviously, this is bigger. Next one is smaller. We reset to 15. Okay, 15 and this one is bigger. The next one is smaller, so we reset it to 13. 13 is smaller than that, right? And the next one is smaller than 13, so we reset it to 10. And this one is bigger. 10, the next one is 11. 10 plus 11, right? 10 plus 11 is smaller than this one, we keep this one. And the next one is part of the increasing sublist, we plus 12. So this one is bigger, right? This one is bigger than that, so we replace the global sum with 10 plus 11 plus 12. Alright?
And then that equals 33.
Yeah, 33. Okay. So for the second example, we always increment the current sum because there's no breakage. Right? There's no breakage. Everything is increasing. Right? Define. We start the function declaration using define the maximum sublist increasing sum. Okay. Array. If not array, if we are given the empty array, we return 0. N equals the length of the array. The current sum equals the first number, ARR 0. And then the answer equals the first number as well. We go through the second number to the end. For I in range 1 to the n. Right, look. If this number, right, if this number is bigger than the previous one, if ARRI is bigger than ARRI minus 1, right, if this number is ARRI is bigger than the previous number, which is ARRI minus 1, then CS plus equals ARRI, right? As we reset it to CS equals ARRI, alright? Look at the difference. If this number is bigger than previous one, then we accumulate it. If not, we start a new subarray, right? Yeah. And then here we need to keep tracking of the maximum. Max answer, which value is it? Can you tell me which value I should put here?
C.
C what?
S.
CS. Where down CS? Yes. And then return which one value? Way down. Okay, so what's the problem? What have you learned? What's the takeaway today?
We have an array.
We have an array of numbers, and then try to say more things. Come on, try to say remember, later you want to teach Daddy, right? Yeah, come on.
Have an array of numbers, and you want to return the maximum possible sum of an
Ascending
subarray.
Okay, so we want to find out the maximum possible sum of subarray, which is increasing, which is ascending. Okay, strictly ascending.
You have CS.
CS, which stands for current sum, and then we have the answer here. So every time we check.
And if it's bigger, you add it.
Yeah, add it to the current sum.
If it's smaller, you start new one.
Start new one by resetting to resetting to the number, right? Yeah, look, this if this is bigger, it's part of the increasing. We accumulate. Otherwise, we start a new subarray with the current number. Am I right? Look, 1, 2, 3, 10, 9, 8, 10. Okay, look, 1, 2, 3, 1, 2, 1, 2. Look, 1, 1, 2, 1, 2, 3. Okay, 1, 2, 3, 10. Okay, now it's decreasing, right? So we just abandon the previous one. We start a new one with here. 9, 9A, which is decreasing. So we abandon this. We start a new one. A 10, A 10. Right? Make sense?
Yeah, that's bigger.
Yeah. Okay.
16.
The time complexity O(n), right? We're just going once the entire array O(n). N is the number of numbers in the array. The space complexity O(1). We are not using any linear space. We're only using constant space. Okay, that's it for today. Bye bye.
Bye.
Bye bye.
Bye.